3.2 Characteristics of Polynomials. I'm Anil Kumar, and here is a test problem for you based on end behavior and number of turning points. Describe the end behavior and possible number of turning points for a quintic polynomial. Quintic polynomial means degree is 5, correct? I'd like you to pause the video, answer this question, and then look into my suggestions. Now, what I will do is I will sketch possible scenarios here that will help you to understand the concept. I know from the previous videos you're very clear about what is end behavior and possible number of turning points for a quintic polynomial. If degree is 5, and let us assume, so we are assuming that leading coefficient an is positive, right, for our sketch. So positive for us means that the right side is up, right? So for the quintic, right side is up and the opposite end, so it will start here somewhere, correct? So based on that, we can always explain. It could be negative. The thing is, it will kind of flip on x-axis, but result as far as the number of turning points is concerned will remain the same, right? So we'll say describe the end behavior and possible number of turning points. So let us first assume that the leading coefficient is positive, and based on that we'll describe end behavior and number of turning points. So when we say case 1, I should have written here case 1 where leading coefficient is positive, right? So if leading coefficient is positive, in that case end behavior is what? End behavior is when x approaches negative infinity, y approaches negative infinity, you can see there, and when x approaches positive infinity, y approaches positive infinity, right? So that is the first case. And the second case is we will take up case 2 when we will say, we'll assume negative leading coefficient. That is to say, if an is negative, correct? In that case, what is the end behavior? Tell me. In that case, end behavior is kind of like this. In that case, negative leading coefficient means it ends up here and it has to begin there, correct? So that means if x approaches, we'll write here, x approaches negative infinity, y approaches positive infinity, right? And if x approaches positive infinity, y approaches negative infinity, right? So that is about the end behavior, right? Now, okay, so we have answered one part of the question, that is describe the end behavior and possible number of turning points for a quintic polynomial. So we know we are talking about a5, right? So in our case, n equals to 5, correct? So we just discussed in general for any odd degree, it is going to be same. N equals to 5 is odd degree, and that is what we are discussing. So we have an odd degree polynomial here, and degree is 5 for us. Now let us now consider turning points. Okay, so turning points, what I will do for turning points, I will assume an to be positive and give you different examples and then reasons, right? So since I have to move from quadrant 3 to quadrant 1, I can go without turning, right? So the number of turning points possible could be, so a degree 5 polynomial can I'll just sketch closer to this, so could be kind of like this. Do you see that? Degree 5, kind of like this. Do you see that? So that could be one option. So let me write kind of equation for this. We are saying positive leading coefficient, and I've just moved this to, let us say, minus 5. So I could say this is x plus 5 to the power of 5. Is that okay? So it is a degree 5 polynomial, and the number of turning points are how many? Well, let me write that before it, okay? Number of turning points is 0. 0 turning points. We are writing number of turning points here. Okay, now let us consider the second function, and this time what we will do is we'll keep x plus 5 to the power of 4 this time, but add 1x. That is to say that, well, it has to turn here now. It has got 2 zeros, right? One here at 5 and then one there, correct? But this 0 is a different kind. It is now of degree 4 at -5. In that case, how the graph should be? In that case, the graph should be kind of like this. Do you see? It has to turn like flat like this, and then it will go like this, correct? How many turning points do we have? 1, 2, right? So in this case, we have 2 turning points. Good job. Now what we will do is we'll kind of change the equation a bit, and we will write this equation as we'll add one more 0 to this, right? So if I add one more 0 to this, in that case, I'm just looking for space here. So we will have equation as, let me use this space, okay? We have x plus 5 to the power of 3, and we could have 1x, which we had here, and then let me use another x somewhere there, okay? So that is x minus 2, for example. Okay, so that is to say we have 2 zeros and we add one more 0, which is at 2, for example. Okay, so this one is at 2. Now what happens? But this is a cubic 0, this is linear, that is linear. Cubic means it is going to turn. It has to turn again here like a linear and then turn back. Good job. So we can start like this, turn like that, but then have to turn and then turn like this. So that is our function. How many turning points? Right? So we have actually 2 turning points here, right? But not more, right? So what we will do is we'll just take now linear zeros and then figure out what happens to the turning points. And since 5 is our degree, we'll take 5 maximum. Okay, so we'll take 1 and let's mess this up, 2, okay, 3, 4 and 5, and we have to move from there, right? So 1, 2, 3, 4, 5. So how many turning points do we have? 1, 2, 3, 4 turning points. Okay, great. Oh, I should have written here. So what we get here is 4 turning points. Okay, so we get 4 turning points when the equation is kind of linear, right? So we could write this as x plus 7 times x plus 5 times x plus 2 times, let us say this point is 4, okay, x plus, oh my god, minus 4. This is minus 2. Correct. So if we have a function like this, then we have 4 turning points. So for a quintic, which is degree 5, possible turning points are what? Possible number of turning points are what? So what we discovered is it is always even, starting with 0, depending on the equation, 0, 2 or 4, right? What is 4? 4 is 5 minus 1 is 4, okay? N minus 1, general form, correct? So that is how you can explain n behavior and possible number of turning points for quintic polynomial in this case. But I think that helps you to explain for any polynomial in general. I hope you really appreciate it. Subscribe to my videos and try to get 90+. That is all I wish for you. Thank you and all the best.